Every single time you book a flight, or check your bank balance, or really just open any app on your phone, you're tapping into this powerful, totally invisible network. These are the secret connections that make our entire digital world go round. But they're also a massive, massive target. So let's pull back the curtain and take a look at what they are, and more importantly, how we keep them safe.
So what is that invisible connection? Well, it all comes down to a simple three-letter acronym, API. It's the silent workhorse of the internet, the unsung hero that makes everything just work. And understanding it is absolutely key to understanding not only how our digital lives function, but also how they can be broken.
All right, so let's dive in. We're calling APIs the digital glue, and that's for a really good reason. They are exactly why your food delivery app can use Google Maps to show you where your driver is, or why a travel site can pull up-to-the-minute flight information directly from a dozen different airlines. They let completely different pieces of software talk to each other like they've known each other forever.
So what is an API? An application programming interface, really? Well, you can think of it like a contract. It's a very strict set of rules that says, hey, if you send me a request in this exact format, I promise I'll send you back a response in that exact format. It's this shared, predictable language that lets all these totally unrelated apps communicate so smoothly. Okay, probably the best way to wrap your head around this is with the classic restaurant analogy. It just makes perfect sense. Imagine you're at a restaurant. You're the user. You want to order some food. Now, you don't just barge into the kitchen and start yelling your order, right? No, you talk to the waiter. The waiter, that's the API. The waiter takes your specific request, goes to the kitchen, which is the server, and communicates your order. And then, when the food is ready, the waiter brings it right back to you. It's a clean, efficient process where you get exactly what you asked for without ever having to see the chaos of the kitchen.
But of course, you can't just have anyone walking into that kitchen and making demands. Restaurants have a host at the door, and the digital world has its own gatekeepers. And this brings us right to the heart of API security, controlling who even gets to talk to the waiter in the first place and what they're even allowed to order.
And that control really boils down to two core ideas you see here: authentication and authorization. Let's break it down. Authentication is all about proving who you are. It's like showing your ID to the security guard to get into an office building. But just because you're inside, it doesn't mean you can go anywhere. That's where authorization comes in. Authorization determines what you can do. Your key card, that's your authorization. It'll open your office, but it's not going to open the CEO's office. You absolutely need both to have real security.
Okay, so if authentication and authorization are the locks on our digital doors, how do attackers try to pick them? Well, it's time to open up the hacker's playbook and look at the most common ways they go after these APIs.
The security community actually has a go-to guide for this. It's called the OWASP Top 10 for APIs. Think of it as the most wanted list for security risks, and it's pretty much the standard that all the pros use to figure out what to defend against first. We're going to look at the top 3 right now.
Threat number 1 is, well, it's terrifyingly simple. Let's say your user ID in an app is 123. An attacker might just go into the web address and change that number to 124. Now, if the API isn't built correctly, it just hands over all of user 124's private data. That's it. It's the digital version of your office keycard accidentally opening every single door on your floor. Scary stuff. The second big threat is kind of like stealing the keycard instead of just guessing the password. See, when you log in, the server gives you this temporary digital ticket. It's called a session token that proves you're you. Well, attackers will try to steal that ticket, and if they get it, they can just walk right in and impersonate you, taking over your entire account. No password needed.
And finally, we've got injection attacks. This is where things get really sneaky. It's like writing a secret, malicious instruction on your restaurant order. So instead of just ordering soup, you write soup, and by the way, also give me the secret recipe. If the kitchen staff, the server, isn't paying close attention, it might accidentally follow that malicious instruction and give away secrets it was never, ever supposed to.
Okay, I know, that all sounds pretty scary. But here's the good news. For every attack, there's a defense. So let's flip the script and look at how we build a strategy that actually defends the system.
So our first line of defense is often something called an API firewall. You can think of it like a bouncer for our digital kitchen. It stands at the door and inspects every single request before it gets anywhere near the server. It can spot and block those malicious requests, stop someone from trying to send thousands of requests all at once, that's called rate limiting, and it makes sure the data is in the right format. It's an absolutely essential guard at the front door. But here's the thing. A shield, a passive defense, is never enough. Attackers are smart, and they are always looking for new ways to get around it.
And that's why the best defense is also a good offense. You have to proactively hunt for your own weaknesses before somebody else finds them for you.
And that proactive process, it's called penetration testing, or pen testing for short. It's basically ethical hacking. You plan an attack, you test the system by trying to break in, and then come the most critical steps, reporting and fixing. See, finding a vulnerability is totally useless if you don't document it clearly so people can understand it, and it's actually dangerous if you don't then go in and fix it. The goal isn't just to find weaknesses, it's to make the entire system stronger.
So, what's the big takeaway here? Your entire digital life, every app, every service, all of your personal data, it's all built on these invisible connections. The next time you tap a button on your phone, just remember those digital waiters and kitchens working like crazy behind the scenes. And remember that at the end of the day, your data is only as secure as the API that's protecting it.